The journey to Mars represents one of humanity's most ambitious endeavours, requiring meticulous planning, advanced technology, and robust emergency preparedness. SpaceX's Starship, envisioned as the primary vehicle for crewed missions to Mars, is designed with redundancy and safety measures to address a wide range of potential emergencies. In this document, we explore how Starship will handle in-flight emergencies, including scenarios such as water supply compromise, pressurization failure, and structural damage. We'll delve into emergency response protocols, communication strategies, crew training, and other essential aspects of ensuring the safety and success of missions to Mars. Maintaining a stable and sufficient water supply is crucial for sustaining life during the journey to Mars and on the Martian surface. Starship is equipped with advanced water storage and filtration systems designed to ensure the availability of potable water for the duration of the mission. These systems include multiple redundant water storage tanks, advanced water filtration technology capable of purifying water from various sources, including recycled wastewater, condensation, and potentially Martian resources. Monitoring sensors to track water consumption and detect any anomalies or leaks. In the event of a compromise to the primary water supply, crew protocols would dictate the activation of backup reserves and the implementation of water conservation measures. Crew members would receive extensive training in water management techniques to maximize efficiency and prolong the longevity of available supplies. Additionally, contingency plans would outline procedures for sourcing water from alternative sources, such as ice deposits on Mars, if necessary. Maintaining a pressurized environment within the Starship cabin is essential for the crew's survival in the vacuum of space. Starship's interior is designed to be compartmentalized, allowing for localized failures without compromising the integrity of the entire vessel. Pressurization systems include redundant airlocks and valves to regulate cabin pressure, emergency seals and bulkheads to isolate affected areas in the event of a breach, backup oxygen supply and emergency breathing apparatuses for crew members. In the event of a pressurization failure, crew protocols would dictate the activation of backup systems and the sealing off of affected sections to prevent the loss of atmosphere. Crew members would don emergency breathing apparatuses stored throughout the ship until the situation is resolved. Mission Control on Earth would provide guidance and support, assisting the crew in troubleshooting the issue and implementing corrective measures. Despite rigorous testing and engineering, the risk of structural failure during the journey to Mars cannot be entirely eliminated. Starship is designed with robust materials and structural integrity to withstand impacts from micrometeoroids and debris. Risk mitigation strategies include reinforced hull and structural components to withstand external forces, impact-resistant materials and shielding to minimize damage from potential hazards, continuous monitoring systems to detect and assess any signs of structural degradation. In the event of structural damage, emergency response protocols would be initiated involving a thorough assessment of the extent of the damage and the implementation of repair measures. Crew members would utilize onboard repair materials and tools to address minor breaches, while contingency plans would outline procedures for evacuating affected areas if necessary. Mission Control on Earth would coordinate with the crew, providing guidance and support in problem solving and resource allocation. Emergency response protocols for in-flight emergencies on Starship are comprehensive and meticulously planned. These protocols cover a wide range of scenarios, including but not limited to water supply compromise, pressurization failure, structural damage, medical emergencies, communication and navigation failures. Each emergency scenario is accompanied by detailed procedures outlining the roles and responsibilities of crew members, the activation of backup systems, and communication protocols with Mission Control on Earth. Crew members receive extensive training in emergency procedures, including simulated scenarios and hands-on drills to ensure readiness for any eventuality. Effective communication and coordination are essential for managing in-flight emergencies on Starship. Communication systems include high-bandwidth data links for real-time communication with mission control on Earth, redundant communication channels, including satellite links and radio frequencies, emergency beacons and distress signals for alerting nearby vessels or support craft. Mission control on Earth serves as the central hub for monitoring the status of the mission and providing guidance and support to the crew. In the event of an emergency, mission control coordinates the response efforts, utilizing data from onboard sensors and telemetry to assess the situation and provide instructions to the crew. Communication protocols ensure that critical information is relayed efficiently and accurately between the crew and mission control, enabling rapid decision-making and problem-solving. The success of emergency response efforts on Starship depends on the training and preparedness of the crew. Crew members undergo rigorous training programs covering a wide range of emergency scenarios, including simulated drills and hands-on exercises. Training modules include emergency procedures for water supply compromise, pressurization failure, and structural damage, medical training and first aid protocols, communication and navigation procedures, teamwork and leadership development. Crew members are selected based on their expertise, experience, and ability to perform under pressure. Each member of the crew is cross-trained in multiple disciplines to ensure flexibility and adaptability during emergency situations. Continuous training and refresher courses are conducted throughout the mission to maintain readiness and proficiency. In conclusion, the journey to Mars aboard Starship represents a monumental undertaking that requires meticulous planning, advanced technology, and robust emergency preparedness. Starship is equipped with redundant systems and safety measures to address a wide range of potential emergencies, including water supply compromise, pressurization failure, and structural damage. Emergency response protocols are comprehensive and meticulously planned, covering a wide range of scenarios and involving extensive training for the crew. Effective communication and coordination between the crew and mission control on Earth are essential for managing in-flight emergencies and ensuring the safety and success of the mission. As humanity embarks on this historic endeavor, the lessons learned from each mission will inform future exploration efforts, paving the way for the continued exploration and colonization of Mars.